What if the rules that govern your world break down at the smallest scales? Where particles behave like waves, cats can be alive and dead, and nothing is truly certain. This is quantum physics, the science of the very small. And it doesn't just describe atoms, it redefines reality. Let's explore what quantum physics really is, and why it's reshaping how we understand the universe itself. Quantum physics, or quantum mechanics, is the branch of science that studies the behavior of particles at the atomic and subatomic levels. It looks at the building blocks of matter, electrons, photons, quarks, and other fundamental units of energy and information. At these scales, the rules of classical physics, the kind that explain planets and pendulums, no longer apply. Instead, reality becomes strange. And everything we thought we knew gets flipped upside down. In the quantum world, particles can behave like waves. Take light, for example. It can act like a particle, called a photon, but also like a wave that spreads out and interferes with itself. This is called wave-particle duality. The famous double-slit experiment shows that a single particle, like an electron, can go through two slits at once, as if it's in more than one place at the same time. But when you look at it, when you measure it, it chooses a single path. Just observing it changes the outcome. Another key idea in quantum mechanics is uncertainty. The uncertainty principle says you can't precisely know both the position and the momentum of a particle at the same time. The more accurately you measure one, the less certain you are about the other. This isn't a flaw in our tools. It's built into the fabric of reality. At the quantum level, things exist not as fixed objects, but as probabilities. Nothing is fully certain, only likely. Perhaps the strangest idea in quantum physics is superposition. It means that particles can exist in multiple states at once. An electron can spin up and down. A photon can travel two paths. It's like flipping a coin, and it's both heads and tails until you look. This idea led to the famous thought experiment. Schrödinger's cat, a cat that's both alive and dead inside a box until the box is opened. It sounds absurd, but superposition is real. Quantum computers are being built on this very principle. Now things get even stranger. Quantum entanglement is when two particles become linked, so that measuring one instantly affects the other, even if they're light years apart. Einstein called it spooky action at a distance. He didn't like it, but experiments prove it's real. Entangled particles share information instantly, faster than light, and no one fully knows how or why. This challenges our idea of causality, and even space itself. Here's where quantum physics gets deeply philosophical. In the quantum world, measurement isn't passive. It changes what's being measured. Before observation, a particle exists in a cloud of probabilities. Only when you observe it does it collapse into a single reality. Some interpretations suggest that consciousness might influence this process, though that idea is debated. What's clear is that reality, at the quantum level, doesn't exist in a fixed state until it's interacted with. Quantum physics isn't just theory. It's behind many of the technologies you use every day. Your smartphone relies on semiconductors built from quantum effects. Lasers and DVDs use quantum behavior of light. MRI scanners in hospitals use quantum spin properties. Quantum cryptography may secure future communication. And then there's quantum computing, a revolutionary approach to data that uses superposition and entanglement to perform calculations far beyond today's computers. Quantum physics is sometimes misunderstood. It doesn't mean anything is possible, or we create reality with thoughts. It's a mathematical framework, tested in thousands of experiments, that describes the most accurate picture of the micro-world we've ever had. But it's still full of mystery. And we still don't know how to fully merge quantum mechanics with Einstein's theory of gravity. The puzzle is far from complete. Quantum physics shows us that the universe is deeper, stranger, and more interconnected than we ever imagined. If this blew your mind, subscribe for more journeys into the weird side of science. Like this video if you believe curiosity creates wonder. And let us know in the comments, which quantum mystery do you find the most fascinating? Until next time, don't stop questioning, because reality is weirder than fiction.